Morning. So we're going to be talking about static analysis today. Who, just first show of hands, who here is familiar with static analysis? That's what I thought. Okay, so you guys have heard a bit about me. New product development, systems engineering, software systems is what my experience is in. Worked with secure decisions. One of the things we are known for is transitioning our research. So one of the research projects that started a long time, it was a Department of Homeland Security, CBER it's called, and that is now its own company called CodeX, and it sponsored this conference. And I also wanted to mention Grammatech. So the work that I'm here talking about today is funded by Department of Homeland Security, Science and Technology, and on a program called STAMP. So that stands for Static Analysis Modernization Program. Government's full of acronyms. And then the prime contractor on that, so the people who won directly to the government, is Grammatech. And then us at Secure Decisions are working on a subcontract to them on this work that I'm going to talk about today. So an overview of the talk. First, we're going to just go over static analysis. Sounds like everybody's familiar, and I don't need to convince you of its merits. But we're going to do that. And then part two is the main part of the talk. So it serves two purposes. One is it covers all the things you need to look at in a static analyzer, and that sort of doubles for the set of information that we're capturing in this system called Compare that I'm basically presenting about. And then the part three, it's a short section, and so there's this system that we're developing called Compare. We're really just getting underway. We've got kind of the initial prototype built, and we're spending the next 12 months really building that out and those capabilities. And that's a set of technologies I'll talk more about. So into static analysis. So static analysis is basically a way of looking at programs without running them and learning about how well they work and if there are problems or other things like that. They work on different inputs, so some work on source code, some work on compiled binaries. Really, they're all there to help find quality problems, right? And that's a broad category of problems. And they're both open source analyzers that are freely available, and you can get their code. And there are also commercial and proprietary tools, right? So people who sell their software. And one of the ways I like to think about static analysis is it's like a security expert sitting over your shoulder, right? And this expert has like 100,000 hours of experience and unfailing attention because it's a computer program, right? But a lot of people have written all these checks into these analyzers, and when you're running that on your code, you're getting the benefit of all that collective wisdom of all these people, like 50 years of research. And so static analysis is really good at finding basically implementation issues, right? It's probably not going to find design problems. There are actually some forms of static analysis that attempt to find those. But most static analysis is finding things like lower level programming mistakes, right? So do you have if you're working in the cloud and you're doing secrets management, if you have secrets hard-coded in your code, that's not a good practice. There are checkers that will look for those types of API tokens and things that are not stored in a secret store. When you're doing C applications, right, your memory management is a real problem, right? So doing buffer overruns and those problems of modern languages have sort of obviated a lot of those, but if you're writing C, you need help finding those types of mistakes because they're really hard to catch. So there's literally thousands of things that static analysis can check for, and there's a big list. And using analyzers has just been demonstrated to really benefit code quality, right? And it's cost effective too. That's an important thing. So there's a lot of things that we could do that are really good, but they're too expensive in practical terms. Static analysis is actually practically feasible too. So Nortel's done studies where they showed that it's economical. Google has built a big system for building static analysis into all of the, it's a system that checks all of the code in that pipeline before it reaches any form of production. Facebook wrote their own analyzer. And then Coverity is a commercial vendor, and they have some published research on their experience with building and deploying that product over the last 20 years. So sign me up. You know, you've convinced me. Static analysis is great. I've got a Java application. It's about this long. I'm using Maven. Wait, what should I do? Right? And maybe even you're ahead of the curve. Like, I need to find me some SQL injection. What analyzer should I use? So just, you know, and today, the state of the art is pretty much like, you know, you see people on the OS Slack channel like asking the room, like, you know, well, what can I get, right? And the reality is that there's just not really a good source of information out there, right? Which is, I think, why you're all at this talk. And so what we're trying to do is build basically like a consumer reports for static analyzers. So we want to catalog them so you know which ones are available, and then we want to document properties of those analyzers as well as and measure some of their performance. And so we're calling that system compare. And there are basically two main goals. One is really just driving adoption, right? So I don't have a dog in this race, but my goal is to help improve the quality of software in the world, right? That is the bigger goal. And I think that, you know, getting software analysis tools better in use is a way to achieve that goal. And in order for people to use the tools, they have to know they exist and what they're good at and which ones they should be using, right? So that's the left-hand side. And then on the right-hand side, there's some nuance here with the proprietary and the open source analyzers. The proprietary makers of analyzers don't always allow you to publish information about their tools. So if I can improve market transparency and create pressure on them to make better informed customers, right? That's a secondary goal. And so I think most of the people in the room here fit into this top category. There's some other people who might find this capability that we're building useful. And like I said, our goal really is to just improve the security and reliability of software. So let's get into part two here. We've identified 7 broad categories of analyzers that you should pay attention to when you're making an acquisition decision. So I'm basically going to go through each of these in pretty good detail. And the slides, if you read into like what's in these slides, that's the type of information that we're capturing in this compare system. Okay, so let's start off with the basic information. So this is just like it just says. So one of the things that you need to know when you're looking at a tool, whether it's up to date. And so when it was released most recently, right, if that was 5 years ago, maybe that tool's not being actively maintained, and maybe it's not as reliable as it should be against modern frameworks and things like that. So we collect, you should be looking at when it was first released and if it's been maintained and it's got a track record, and then when the latest release was. Where you run it. So matters a lot to a lot of organizations. Maybe you don't want to be sending your source code up to some outside provider, right, in a SaaS model. So you will be looking for self-hosted tools. And if you are self-hosting, you know, the platforms that you are adept at running, like what does it support? There are licensing models, whether you have to pay for it or whether it's free, and then you know, you should be able to go and get more information from that tool itself. So process integration is one of the most important categories that I'm going to talk about that I think maybe people don't pay as much attention to. And so Google's got some, in their published papers, and Facebook as well, they basically talk about how really utterly important it is to integrate these tools in developer workflows well, right? So if people have to come out of where they're working and go into the static analysis tool, getting people to adopt that and use it in practice you're going to be facing an uphill battle. So that's a lot of the insights. And so you really need to bake it into the processes. And you can't just consider a static analysis tool in isolation, right? Like that's not how it works. We have environments where you're doing development, and the static analysis is going to fit in this environment, right? So here we've got a simple diagram where we've got developers writing code down here, checking it into version control. Maybe it's getting automatically built for them, and you've got artifact repositories and testing taking place, right? So in this system, there are multiple stakeholders who need to look at the results and use it. Oh, actually, I broke this down, I forgot. So first, let's look at where it needs to run, right? So the analyzer needs to run, it can run in different places. So there's actually different levels of analysis. Some actually you can run right in the developer's IDE or on their workstation. Some might need a separate standalone server with more compute that you can dedicate. And maybe some run right in the build server itself. And then there's different features within each of these deployments, right? So can the analyzer handle live coding updates? Is it giving me live feedback, or do I need to kind of kick it off on a pre-commit hook? Things like that. On the standalone server, maybe it takes a long time to run. Maybe you want to run that nightly. Do I have the ability to schedule it? These are capabilities that some analyzers offer that you should be looking at to see if they're going to meet your needs. What inputs does it require? So different analyzers require different inputs, and so that's going to be related to the deployment location. And maybe some of these things, maybe you want to run static analysis on third-party libraries that you've acquired that you don't have access to the source. So if the analyzer requires source code, you're not going to be able to use that analyzer, right? So you need to be looking at the types of analyzers and the inputs that you can provide that analyzer in order to make it all work. And then the stakeholders that I mentioned, managers have different information needs than developers, than security and audit staff, right? And all of them are interested often in the outputs of static analysis. Just talking a little bit about these API integrations. So one common thing that you need to do with an analyzer is get information out of the analyzers, and you can do that with things like the Serif format, which is a static analysis results interchange format, or just APL or JSON and things like that. A lot of the tools actually have their own dedicated integrations with things like issue trackers and systems like that, right? Work tracking systems. And then there's also vulnerability management systems. So as you start using more analyzers, oftentimes you'll find that it's challenging to manage all of the results from all those different tools. So you want a tool that can correlate and normalize all of that tools into one common system. And there are tools for that. Okay, that was the process integration slide. There's a lot of things to pay attention to when you're thinking about process integration, right? People, technologies, and tying in with all the things that you've got. Speed and scalability. So this is pretty much like, can it do the things you need it to do? And the things that you need it to do, people usually think of time when they think of static analysis, but there's code base size or code base complexity, right? These are the things here. So some analyzers will exhaust memory if you've got a really complex problem, right? A big application, and you try to do it all at once. So how much of the code base you can analyze at any one time is something you need to pay attention to. How many projects can be scanned? Maybe that's just a licensing constraint, but it's something you need to pay attention to. And how long it takes to work. So there are a lot of different checkers written into analyzers, and analyzers there's a bunch of different underlying technologies, and they all work in different ways. Some of those analyses take lots of hours. Other forms of analyses are really quick, like sub-second or couple seconds, right? Just because it's a couple second check doesn't actually mean it's inferior. Sometimes you get just as good performance, if not better, out of these quick checks than you do the really in-depth ones where they're building big complex internal representations of your program's execution, right? So understanding how long it takes and which checks are being run is important. And then low-level things like, does it have the ability to parallelize? Like, am I going to be able to deploy this in a way where it can scale up to the needs that I have? And reporting here. So getting the information out of the analyzer, right? The analyzer learns all this stuff about your software, and then you want to learn about it. So does it have its own dedicated user interface, right? Or is it just spitting out stuff onto the command line or in an XML file, right? Reporting, so when you're having audit teams come in later, being able to report, or management being able to come in and look, does it have hierarchical reporting? Can I roll up like a division's findings and put it into a summary view? Do I have role-based access in that product? So do auditors see different things than developers see, than security staff? Suppression is a popular feature. Once you've looked at an issue, that's called a triage process, where you're going through the findings. Not all the issues are always real. They're not necessarily a false positive, but maybe you just don't care about them, right? So, and it gets complicated when you care about a check in one place but not another. So you don't want to just turn off the whole rule. You just don't want to know about it in this one instance, right? And that's called suppression. And so you can, there's different strategies for suppressing findings, but basically you're telling the analyzer, like, hey, stop telling me about this. I know, I don't care anymore, right? That's an important capability. And then showing differences, understanding how things are evolving. And then last category here, before I get into some of the meatier ones, support. So does the analyzer have documentation on how to use it, how to integrate it into your environment, and the project health? So what we found for the project health, so it's important to, a lot of the times you might want an analyzer that's supported, right? So maybe the tool does exactly what you need and it's going to be fine and you don't really need it to evolve. But usually technology is moving around at a pace where you want that, you want an active community, so that as your framework changes and some breaking thing happens, that community is going to be there to fix the analyzer and make it work on your new framework or whatever, right? Measuring open source project health is its own thing. There's a Linux Foundation chaos system that'll do it. Black Duck has their Open Hub measures. That's a public website. So we found it's better just to link to those, because there are a lot of different measures of community, how big it is, the commit frequency, I don't know, there's a bunch of metrics. You can look them up on those. So now getting into some of the more technical measures of an analyzer's performance. These next two categories are coverage and results quality. So coverage is really important, and it's the extent to which an analyzer can actually look for things in your software. And that's really about two questions. So first of all, will it work on the software that I have, right? So if I have C, Java Analyzer is not going to be so good for you. And if I have source code or binaries, right, it's got to accept those inputs. And then the second one is much more thorny, right? And it's about, can the analyzer find the issues that matter to you? And so we know from NSA research that analyzers, any one analyzer on average is only going to find about 14% of all the types of problems that we know to check for, right? That static analyzers are capable of checking for. One of them is not going to find very many of those. So that sort of suggests you're going to need multiple analyzers. But there's this idea of coverage. And it's weakness coverage, like the types of weaknesses that exist in your code that you want to be able to find. And then results quality, which is how well it can detect those issues, and then how useful those issues are to the people who need to consume them. And so this also breaks down into two questions. So can the people who are reading the results of the analyzer understand it and do useful things, like fix the problem, right? Or determine if there's enough risk there that they want to worry about it. So a lot of these analyzers, have explanations that are paired with their output. Sometimes they can give you a confidence, so it's not necessarily deterministic that there's a problem, but they can tell you like, yeah, I'm pretty sure, or maybe not. And then a lot of the context. So one of the things that's helpful to a human who's trying to understand a result is where it is in the code base, where it is in the data flow or the control flow, and understand why that analyzer kind of thinks about that, right? Helps you basically check that you agree with the result. And then how well does it detect issues? So the technical performance measures. So we're looking at here things like the ability of the analyzer to do the recall on that coverage, right? So basically, like how many different types of issues can the analyzer find? And of the things that it can find, how often does it tell you something that's true versus something that's false? So if it's giving you a warning, oftentimes a lot of those warnings are actually not really problems, right? And so we can, you can measure that with metrics like precision and accuracy. They're all subtly different, but they get at the same idea. So those are the things that you should be paying attention to when you're looking at analyzers. And so now I want to tell you about the Compare platform. So Compare is actually much more than just the website that's the public face of it. It's actually the set of technologies that we're using to gather all the information about these analyzers and then also do benchmarking to get at some of that results quality information about the false positive rates and things like that that I mentioned. And so a big part of this is going to be getting the right test suites in place. That's a challenge, but it's an important one. And so we'll use these test suites to run the analyzers against them, see how long they take to run, and then also whether they're actually finding things, which types of things they're finding. And we're probably going to be measuring that against the claimed coverage, right? So it doesn't really make sense to dock somebody points if they're not even trying to find it, right? So if we can capture in our model of a tool what it's trying to go after, then we can measure how well it's going after what it's claiming, right? It's like billiards. It's like calling your shot. Yeah. Yeah, they're going to be there. We're going to extend existing open source test suites. So National Institutes of Standards and Technology, NIST, has test suites for largely C, C++, and Java. So there's one test suite for C, C++ called Juliet. Those are artificially constructed test cases. So it's like custom written code that's there to illustrate a problem. People have some problems with the artificial test cases, right? OWASP has a benchmark for Java. And then there are also whole code bases, like Asterisk is one, and there's a couple others that I don't remember offhand, that actually where we've got the CVEs disclosed against them. And so if you pick a known version of an application, we can basically scan those applications, and they're real applications, they're open source applications. We can scan them, and then we know where there are specific weaknesses of a specific type in a code location, right? And then we can see if the analyzers are going to detect them or not, and use that to generate metrics. Does that answer your question about the test suites? Yeah, the test suites is always a sticky issue and the particulars of it. I think our perspective is that something's better than nothing, so they might not be perfect, but I could write I don't write analyzers, that's full disclosure. But I could write an analyzer that gets a perfect 100% SOAR. I would just always warn, right? But that's not practically useful. So it's a much more complicated answer, but what we're going to be trying to do is distill the information, all that lower level information about coverage and precision, recall, things like that, and distill that up into something where you can look at it, maybe it has a score or a few scores. And so we're really going to be working to distill that information and make it useful. And so we're going to be open sourcing all the test suites that we use. We're probably going to not write most of them ourselves. We'll probably extend and or modify existing ones, and they're all open source already. And then we are going to have orchestration to run, we're going to build automation to run these analyzers against those test suites and generate that results quality information. And then there's automation that you need to label the results and give them credit, give their analyzers credit for finding things or not finding things. And there's actually difficulties in there because there's multiple valid reportable locations for any type of defect, right? So if you think about within a method, right, you've got maybe a statement where you dereference a null. I'm just going to do C because it's easier for me. Right? You dereference a null pointer, right? You could basically validly say, like, maybe it's at the method level you want to declare that, like in this method, like there's a null dereference, or maybe you want to declare it back when the variable got instantiated, like this thing's going to go null, or where it actually gets dereferenced is maybe the problem, right? But those are all kind of, if you showed those all to a developer, they might nod their head and be like, yeah, I see what you're getting at, and these are all valid reportable locations, right? And so from the giving the analyzer's credit standpoint, makes our life very difficult. Because if an analyzer tells me something and it doesn't exactly match to the line number that I was expecting, I'm not going to give it credit, but maybe it should have gotten credit, right? And so that's one of the issues that there is when it comes to benchmarking these things. So that's something we're going to work through. I think we have an approach, I don't have the details, but we're going to be publishing all our methodologies, and that's actually one of the reasons I'm here, is to get feedback. So if people have opinions on how to do this, or they've tried to do this already, please come up and talk to me afterward. I would love to hear your approaches. And then there's also on the right-hand side here, all the collecting of that information. So there are a lot of analyzers out there. So we've identified about 600, which is surprising. Like, I had no idea there were that many. And a lot of them are really tiny, and we probably won't catalog them. We're going to try to focus on ones that have good coverage over the weaknesses that we care about in the languages that are popular, and get the most popular ones first, and then work our way down. But collecting all that information is a lot of work. And so here's just a block diagram view of the system. So we have the top left corner is basically the website, right? That everybody in this room would interface with. We're thinking about having ratings and reviews. So a lot of the license terms from the proprietary vendors or proprietary analyzers don't allow us to publish that results quality information I was talking about. So we might use ratings and reviews as a surrogate. We have other strategies too, where we might support bake-offs internally within organizations. So they have the evaluation licenses. They're using our technology inside for the automation and running the bake-off. And that way they have access to the license. They're only viewing the results for themselves, and we don't have any disclosure problems. Databases, the benchmarking, yeah. And so today, this says May, so we were working under contract, and then some funding things happened, and we took a vacation for the summer, and we just started beginning of September again. So we're just getting ramped up here, or September 30, sorry. So we're just in the first couple weeks of getting ramped back up. But what we've built so far is this site here. So we've got a landing page. We've got a list of the analyzers that we catalog. And you can do some filtering on that. So you can filter by programming language, or actually any of the attributes that we store. So there's a filtering control at the top of that list, and it just shrinks right down as you add criteria. So you could filter for open source or free tools. You could filter on language, whatever you want. And then here we've got the details page. So if you click on any one analyzer, you can see its details. So we have these 7 categories, and all the information is cataloged in there. And then for a couple of the tools, so Clang is one. That's the Clang static analyzer. We have benchmarking data from an older version of it, courtesy of NIST. And we present that information here, some of those metrics about how well it's doing. So here you can kind of see it's like a little grid. There are 100 circles there. and it's finding, I don't know what it was. It's like 3, 6, 9. It's like 10 of the 100, right? So it's got about 10% coverage of the types of weaknesses, and then it's throwing one false positive out of those 10. So we had a visual representation of that performance there. So we've got the 73 cataloged, and one of the things that we've got built in, so you can't really see in the screenshot, but oftentimes we have missing information for analyzers. So we've done our best job to go and get the information. It's not always publicly available. We've been doing outreach to the makers of them. They're not always super responsive. But in order to prioritize our efforts, feedback from what people are interested in, we built this little feature so you click it and it registers on the back end for us. Hey, I'd really love to see information here, right? So basically, for each of the sections, if it's missing, you can vote, and we see that on the back end, right? And we can use that to prioritize our efforts for data collection. So some of the challenges, I think I've talked through a lot of these. Collecting information by analyzers is time-consuming. The benchmarking is tricky. So getting the right test suites in place, giving those analyzers credit for detecting the real issues. And really just getting this whole thing stood up, right? So it's a whole organization we're trying to stand up, or the technical system, right? So we got to collect the information, got to be able to generate benchmarking information, publish it, and then figure out how to make all this self-sustaining. And so with that, I'm going to leave you with some URLs. So there's the website itself. We've also got a couple surveys. So the top survey is where anybody can come in, just tell us, like, you should really know about the whatever analyzer, and I'd love to get it in the catalog. That's a very quick survey. It takes like 10 seconds to fill out. If you are the maker or vendor of an analyzer, we have a much more detailed survey, which basically, for all those categories of information, we have a form where you can input the answers, and then we can take that and put that into the catalog so that it'll display on the website. So that's the detailed survey. And then if you are curious about the analyzers that we've found, we have a Trello board where we sort of been using that to keep track of which analyzers we've collected information for. So you'll see there are about 6 columns in there, right? So analyzers we know that exist but haven't gone and collected information for. And then we have analyzers, the collection, we have like a little internal review process. So there's a couple of those in-process columns. And then we have 3 columns on the right that basically amount to how much information we collected. So just a little bit, right? Like we just have the URL and a language and a few other things, versus we have a much more complete picture of that analyzer. And so we're trying to keep track of that. And so we'll be building out that back-end technology for ourselves to manage that. But for now, we're using that Trello board. And so if anybody wants to email us, that's our email address. And that's my talk.